Alrighty, section 7.3. 7.3 has to do with the number of solutions of a system. Now you remember, the solutions of a system are just the x and y points, so the intersection points. Okay, so if you're going to graph two lines, you could get a few different situations. You might have one line here and one line there. And guess what? They intersect at one point. That's usually what we're looking for. Now, it's never going to be two because in order to come across, right, that would be a curve. That's not the case. These are straight lines, right? As they move further and further away, they get further and further away from each other. So you could get one point of intersection. Okay? We know that. So you could get one intersection point. If I can spell intersection, point. That's our most common case. That's what we're usually looking for. Here's another case. Maybe you've got one line here, and you've got a line right beside it that's parallel. So these are parallel. If they are parallel, that means they have the exact same slope, right? That means that they're always the same distance away from each other, this distance. There is 0 intersection points. Intersection. In other words, they never ever meet. This would be a case where you're trying to solve some problem. It means there's never a solution. It's never going to happen. They're never going to meet. So that is another possibility. Now, the third possibility is kind of silly, and it is a possibility, but here's what I'm going to do. I'm going to do one line there, and then I'm going to do another line here. The other line is right on top of it, okay? So it's really the same line, just twice, okay? So it's one line, and then the other line is completely on top of it. It's parallel, and it's right on top. These are parallel, but one's been moved over, right? These are parallel, and it's the exact same line. So in other words, they hit here, and here, and here, and here, and here. They intersect at how many points? Well, seeing as it goes on forever, there's an infinite number of points, okay? So in other words, these are called coincidental. Coincidental. That's no coincidence. One line is right on top of the other ones. So in other words, there's not one point. It's not 2 points. There's an infinite number of points. So in many ways, it's not really a system, right? System means two different equations. No, this is one equation, then the exact same equation. So one line and then the other one's right on top of it. There's an infinite number of intersection points. Okay, so yeah, we say that these are intersecting. That was our first case. Or they could be parallel. Parallel. Or the third case they're called is coincidental. Coincidental. And the resulting systems, well, it may have 1 or 0 or an infinite number of intersections. Intersection points. Okay, so you can predict the number of solutions by simply looking at the slopes. So if we look by looking at the slopes, right? The slopes of our two equations, of the equations, or in other words, the lines. Let's take a look at the slopes of the lines. And you may not even have to graph them. What? Yeah, if you can figure it out, you may not even have to graph them in order to say, hang on, I know there's one solution or two solutions or no solutions or something like that. Okay, so hang on, let's figure this out. How many solutions? Now, it doesn't say find the solutions. It just says how many. Is it 1? Is it 0? Or is it an infinity? I don't know. Let's figure, that's what we're looking for. So I need to figure out the slope of this one. So remember, to figure out the slope, move the 3x over. So 6y is equal to minus 3x minus 3. Minus 3x plus 12. I don't want 6y, I want divide by 6, divide by 6, divide by 6. So here we go. Y is equal to negative 1/2 x plus 2. Slope is negative 1/2. Okay? Whoa, look at all this stuff. This is weird. Okay, 2x plus 14y is equal to 28 subtract 5x. All I want to do is I just want to figure out the slope. So subtract off 3x from both, subtract off 2x from both sides. I'm going to get 28 subtract off. So minus 5 minus another 2 is going to be minus 7x. That's 14y. What do I do now? Divide by 14, divide by 14, divide by 14. Divide by 14, divide by 14, divide by... Okay, so here's what I get. Y is equal to, I'll do this one first. Negative 7/14, negative a half. Hang on, same slope. See that? Slope's negative a half, negative a half. That means they're parallel, right? It means that they're parallel and there's no solutions. Now, if they had different slopes, they always hit at one, period, only one. But as soon as you have the same slope, they're parallel. Or are they? Or are they coincidental? Is it the same line? What? Hang on. What's 28 divided by 14? Well, that's plus 2. You see that? Oh, I didn't see it. This slope is negative a half, positive 2. Slope is negative a half, positive 2. It's the same line. So now, if the y-intercepts were different, they would be parallel. But it's the actual same line. So there's an infinite number of solutions. Solutions. So in other words, these are coincidental. It's the same line. Now, do I need to figure it out? No. It just says how many? There's my answer. Now, careful. Don't say the answer is infinity, because infinity is like a huge, huge, big number. No, no, no. It's the number of solutions. There's an infinite number of points. That's my answer. Okay, let's try this one. Same thing. I just want to solve for y equals. So remember, 15y is equal to, move the 13 over. So plus 13 to both sides, minus 12x to both sides, minus 12x. Okay, so I'm going to go divide by 15, divide by 15. But yikes, that's not a very nice number. However, I don't care. I'm just looking for the slope. Y is equal to negative 12/15 divide out 3. So it's negative 4/5 of x. Okay. And plus 13/15. That's not a very nice number. I'm glad I'm not graphing this thing. Let's do the same thing over here. Solve for y equals. Okay, so plus 10 to both sides. Like, I'm going to leave the 4y alone. Plus 10, plus 10. Minus 5x, minus 5x. Guess what? I'm going to go divide by 4, divide by 4. I get the same. No, hang on. This is 4/5. This is 5/4. They have different slopes. They have different slopes. Different slopes. Which means it's not this and it's not this. They only intersect at one. Guaranteed. Now, I don't know where they intersect. I also don't care. If they have two different slopes, doesn't matter if one's positive and one's negative, as soon as they're different slopes, they have one solution only. Guaranteed, it will always be one solution because they have different slopes. That's the reason why. Okay, so I bet you this one's going to be 0. Well, let's see. Once again, let's solve for y equals. We'll try and figure out the slope. Instead of moving those, see, this is a minus 3y. If I go plus 3y to both sides, positive 3y, plus 3y, right? Those two disappear. So I end up with 2x minus 15. Okay, divide by 3, divide by 3, divide by 3. And you know what? Now I'm going to write it the correct way. I like it better this way. Y is equal to, so 2/3 x, slope is 2/3, right? Minus 15 divided by 3 is 5. So the y-intercept is, there's my slope. Slope is 2/3. Okay, so let's figure out the slope for this one. Once again, see this? It's minus y. Let's go plus 18y to both sides. Plus 18y. So here's what I get. On the right-hand side, I got 18y is equal to 12x plus 80. Okay, now, what do I want to do? Divide everything by 18. Divide everything by 18, and you know what? Now I'll write it in the right order. Y is equal to, so 12/18, divide out 6. Guess what? You get 2/3. It's the same slope. However, are they parallel? I know the slope is the same. Or are they, well, what's 80 divided by 18? 80 divided by 18 turns out to be 5, but it's plus 5. See that? Minus 5 is the y-intercept. Plus 5 is the, these are different lines. It's not the same line, right? Careful. In this case, we got the exact same line. These are different lines, but have the same parallel slopes. So there is 0 solutions. And if it says explain your answer, well, they're parallel. Duh. And they're different, right? They have different y-intercepts. This one's down 5. This one's up 5. I'm not actually going to graph it. I don't care. All I know is that there's no solution. So I don't need to graph it. Okay, let's look at this one. It says the following system has no solution. That means that they're parallel. So I know that the slopes are the same. And they have the y-intercepts have to be different. So same slope, however, the y-intercept has to be different. They have to be, if it was the exact same, then they'd be the same line. But it says that there's no solution. Great. So let's solve for y equals. Once again, let's go plus 3y to both sides. Here's what I got. I got 3y is equal to x plus 15. Positive x plus 15. So in other words, divide by 3, divide by 3, divide by 3. Y is equal to, well, 1/3 x, right? Divide by 3 is like saying 1/3. Same thing. Plus 5. So I know that this thing has to have a slope of 1/3 because they're parallel. And what about c? I don't know what c is, but once again, let's just solve for y equals, right? This is why we love the y equals mx plus b, because it tells you so much. What is y? So 4/12, guess what? That's 1/3. Well, we already knew that. Cool. And then c over 12 plus c divided by 12. I don't know what c is. But it says, what can it not equal? Hang on. If this was equal to this, so in other words, if this y-intercept was equal to this y-intercept, they would be coincidental lines, but they're not. So in other words, I don't want these to be the same. This could be anything else, it just cannot equal this, okay? So not equal to. That's why it says, why is it not equal to? So in other words, you remember, if c over 12 was equal to 5, right? If this thing was equal to this thing, they would be coincidental. They'd be the same line. I don't want that to happen. So I don't want that to happen. So here's what I'm going to do. This is just like solving an equation, but not saying equal to, not equal to. Remember cross multiplying? C times 1 is equal to 5 times 12, which is 60. Oh, I don't want that. I want this. There it is. I don't want it equal to 60. What can C not equal to? C can be anything in the world, but if C is 60, then 60, right, 60 divided by 12 becomes 5. Then they become coincidental lines, and they do have a solution. There's an infinite number. But this question says they have no solution, which means these are not the same. So no, no, no. I don't want this equal to this. That's the only thing that C cannot equal. That's kind of a weird question. Okay, let's actually do one of these as a word problem, and we'll actually graph it. It says Brian makes $22.50 an hour. Jody makes $100 every day, and she makes $14 for every hour she works. Okay, so she makes $14 plus 100. Now, if she only works for 1 hour, she makes $114. If Brian works for 1 hour, he makes $22.50, right? But at some point, they're both limited to an 8-hour day. Is there ever a case where they make the same time and the same pay? Time and pay, that's the things that we're looking over at. This are two variables. So one's going to be T and one's going to be P. Use the system, justify your answer. So step 1, T is going to be time. So the time worked. So what are we talking about? We're talking about per hours, right? This is in hours. And P, I'm just going to call it P. P is your pay. What is your pay that was earned? So in other words, how much? And that's going to be in dollars. Okay. So there's my two variables. I need to have two equations. Which one's x, which one's y? I don't remember. But you know what? Oh, I kind of remember this. Oh, let's see if I can do a better job than that. That's terrible. I want to try and make a straight line. There's my y-axis. If ever you have an x-axis where it's time, oh, that's right. This is going to be t. This is going to be time. So time in hours. Time in hours. Now careful. It says Jody makes, they're both limited to an 8-hour day. So should I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, we'll just stop this off at 8 hours. 2, 4, 6, 8 hours. 2, 4, 6. So that's the only part of the graph we're going to use. I need to know some equations. I know this is going to be pay, P, so this is pay in dollars. I'm probably not going to go 1, 2, 3, 4, 5. No, because he's making $22.50 in the first hour. Let's figure out some equations here. So for Brian, what is his pay? I don't know. It says he makes $22.50 every hour. period. So your pay is equal to 22.50, 22.5 times T. Whereas Jody makes $14 an hour plus 100 right off the bat. Oh, okay, that's different. So Jody pay is equal to, well, it's $14 per hour, so 14x plus 100 guaranteed. I see it. See, this is like saying y equals mx plus b. So this is y, x, I put in x. It should be t for time, right? $14 times the number of hours plus 100. So in other words, this is your y-intercept. This is your b, and your slope is, now, are they going to intersect? They should. They do have two different slopes. So there should be one point of intersection. Excellent. So Jody starts at 100. I don't know any, count by 1, 2, 3, 4. So you know what I'm going to do? I'm going to kind of cheat. What is Jody's, think about function notation, at 8 hours, how much would she make in an entire day? Her pay is equal to 14 times 8 plus 100. Because I know she starts off at 100, but I don't know if this is 1, 1, 2, 3, 4. So this is 80, 32, so this is 112 plus 100. So for a full 8-hour day, she would make 212. So that's the maximum she can get up to. So I need this to be around 212. So what? 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Nope, I can't count by 20s. 20, 40, 60, 81, 100, 20, 40, 60, 82. 2. Yeah, that'll work. So this is 100. I'm counting by 20s, right? 20, 40, 60, 80, 100. 20, 40, 60, 80, 200, 220, etc. So whatever I use for my scale, it's got to be the same. So this is 20, 20, 20, 20, 20. You can't go 20, 30, 40, 50, 60. No, it can't. So let's graph this one first. Jody. Jody starts at 100. I know, y equals mx plus b. Okay, and then I want to go up 14 and over 1, up 14. It's not a very good way of doing it, is it? Because it's not. Should I go up 28 and over 2? Up 28. You know what? At 8 hours, I already figured out she makes $212. So you know what? I could go over to 8 hours. I could estimate 212, and if this is 220, 212, there's 210. 212 is going to be a little bit higher. Not very much. As soon as I've got 2 points, I've got a straight line. Now, I don't know about you. You probably have a better straight line than mine. Well, it's not that bad. So that's going to be Jody's pay. She starts at 100. Remember, that's her y-intercept. Now I'm going up 14 and over 1. Up 14 is kind of hard to estimate, isn't it? But if you do have a ruler and you know 2 exact points, there we go. Cool. So that was Jody. Let's do Brian. I'm going to do Brian in a different color. Brian makes $22.50 an hour. So in other words, he starts, right, plus 0. Brian starts at 0. At 0 hours, you've made $0. Okay, well, that makes sense. At 1 hour, he's made $22.50, which is 22. It's kind of hard to estimate, right? What if I said at 2 hours? So $22.50 times 2, $22.50 times 2, he makes $45. Okay, so 20, 40, there's 60, there's 50. I could estimate around there. Okay, that's not bad. But you know what? Maybe I'll do the same idea. Let's figure out how much he makes at 8 hours, right? At 8 hours, how much would his pay be? So 22.5 times 8. Okay, hang on. What's 22.5 times 8? 225, boop, 8. 40, 4, 16, and 4 is 20. 8 times is going to be 8, 16, and 2 more is 18 with, okay, he makes $180. At 8 hours, he makes $180. There's 100, 20, 40, 60, 80. So if I had a ruler, I could make a straight line. Da, 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 da. That's not bad. Oh, I put this in the wrong spot. Boop. Let's get rid of that. That was going to be 212, 220, 210 should be there. And it's going to be blue. Okay, let's do this one in blue. Doop, doop, blue. But hang on, you'll probably notice something. Oh, it's terrible. These two lines don't intersect. Now, they will eventually intersect, right? if I was to extend this line, and let's bring back the red. If I was to extend this line, you could see that they're going to intersect somewhere. So probably around here. But it would take like 9 or 10 or 11 hours. Okay? So I know they're going to intersect because they have two different slopes. The red one has a slope of 22.5. The blue one has a slope of 14. Now that was kind of hard to figure out, but I just figured it out from 2 points, and then I used a ruler to straighten them out. So I know that they are going to intersect. Is there ever a case where they make the same time and pay? In other words, the intersection, use the system, but they're limited to an 8-hour day. So in other words, my lines have to stop here. I can't extend them. So if you can't extend them, do they ever make the exact same time and pay? The answer's got to be no. Now, it's not because they're parallel, but it's because they're restricted to an 8-hour day and I can't extend beyond here. So no, they are restricted to an 8-hour day. Restricted to an 8-hour day. If they wanted to work longer hours, then yes, they would intersect. But in this case, the answer is no. So what was the question? Is there ever a case where they make the same time and pay? No, there's not. Explain your answer. I just did. You can see that they're restricted to that line, and they have to stop there because I can't go beyond 8 hours. Okay, so this is the last part of Chapter 7. Chapter 7 is doing them graphically. Chapter 8, we're going to start doing these things algebraically where you don't have to draw the graph. But these ones turn out to be pretty okay. So good luck with these questions.